Okay, I have started the recording. I'm going to hit stop share and I'll turn it over to the presenters.
Good afternoon, everybody. I hope everyone's having a fabulous day so far. My name is Tien. I'm one of the instructional coaches with the LKDSB program team, and I'm really excited to launch our session on the Lawson Continuum Multiplication Session 1.
And hello, folks. My name is Denise. I'm also here as a presenter. Happy to have everybody join us today. I just wanted to touch base with everybody, remind them that in addition to tonight's session, we have other sessions coming up on addition and subtraction and multiplication and division. So here they are on the slide. They're Tuesdays and Thursdays. Love to have you come and join us.
We really want to just take a moment and thank you for choosing to join us today. Your commitment to learning and to supporting our students is really commendable. We know you're in the midst of progress reports and also cross country, and many of your intermediates are heading off to Muskoka Woods. So just wishing you a really safe trip and just a very sincere and genuine thank you for your participation today. So we wanted to start a discussion today with sharing some of your ideas about what was your favorite or maybe most challenging math fact. Everyone kind of has a math fact that they really struggled with or that just they thought was really cool. We'd love if you could share that in the chat today.
Post anything, so 1,000 apologies.
So Pam's favorite fact is 8 times 7. I always found that to be a tricky one. Kate's is 3 times 7. Interesting that times 7 is a common example. 8 times 6. 6 times 6. Interesting. I could never remember 7 times 8 and 9 times 6. That was one of mine. I always had trouble with that. Sir John Morton likes 3 times 7 as well. Lucky number 7.
One that was always tricky for me was 11 times 12. I had a hard time keeping my ones separated.
Love. Love the 9 times table. Finger tricks. That's still a favorite.
That's a favorite one, yep.
Still a favorite amongst kids. Well, thank you for sharing your ideas. One of the things that we know is that a huge part of the math that we do with students is about identity and our beliefs, and multiplication often helps to shape that for us. So we're really excited to jump into today's session. But before we're going to quickly recap the very first session that we did last week.
So last week, last Thursday, as a matter of fact, Heather joined us for the first of our online sessions, Why the Continua. Heather gave us some great background information about the creation of the addition and subtraction continuum, and we discussed how the developmental continuum was structured. Some important points were raised about how using the continuum helps us to get to know our students, how it drives our classroom instruction, and ultimately how it supports teachers to improve student learning. There were some curious questions that were asked by some members of the audience last week. And so we are again asking you if you could just take some time and any questions that arise, post them in our chat and we'll try and see if we can bring those to attention and get some answers for you. So session number 2 is going to be on multiplication and division today. It's our second chance to get together with Heather, and we're going to be looking at some very specific strategies and key ideas that are addressed on the continuum. We're not going to address all of them. We have 3 sessions that deal with our multiplication and division continuum. Today, there are some that we're going to address on the next slide. Thank you. So just as it says here, these are the 4 key strategies we're looking at. We're also looking at the big idea of unitizing. That has some great foundational work in these strategies.
But before we do, we want to make sure that we welcome and thank Heather Wark for joining us. She has worked for over 10 years with Alex Lawson, and as a matter of fact, her master's research formed the basis of the multiplication and division continua. So we're very fortunate to have her join us throughout these sessions and share her professional knowledge.
Hi, everyone. Thanks, Tien and Denise, for giving us that great recap, putting our brains back into the headspace of math education and the continua specifically. And I look forward to all of your questions. So please don't be shy in that text chat. If something comes up and you have a connection or a question, please share that with us in the text chat. So just to kind of remind us, some of you were probably here in the last session, but maybe some of you weren't. So I just wanted to touch base on this idea of teaching developmentally. So just like we wouldn't expect any one of these kids to be able to run before they're ready. It's sort of the same with mathematics. So the different strategies will happen with support from teachers, with some instructional choices to support their growth. But they kind of each strategy needs to happen along the road. So, but of course, even these 3 images, they're just part of the development of human locomotion. This does not, there's a lot more to human locomotion than just these 3 little pictures. So just wanted to give, before we head down the path of multiplication and division, just wanted to take a look at a bigger picture of mathematical development. This image was developed by Pam Harris to illustrate how she sees mathematical reasoning develop. And so over here on the left, I think I can turn on the pointer, yep. Over here on the left, we've got counting strategies, and then that builds and becomes additive thinking, and then that builds to help become multiplicative reasoning, and so on down the line. So where does what we're talking about today fit in? Well, basically, if we took a magnifying glass and looked at this section of the development of mathematical reasoning, that's kind of where we're hitting. So the continuum for multiplication and division would fall in here, and actually the continuum for addition basically falls in this kind of territory. So, but the one that we're going to look at today falls in just around here.
Just to interject,
yep.
That image is in our show notes, which we will be sharing a link to at the end of the video. So if you'd like to dig in further, that link will be provided.
Thanks, Tien. So, and then this is that picture blown up pretty big. Some of you will be familiar with different pieces in here. We did do a redraft this June, as you can see in the heading. And so there has been some shifting around as we learn more about how students develop number sense, and also as we learn more about what we think is the most important things for students to develop the types of strategies that actually will help them become multiplicative thinkers. So that it has informed some of the changing, some of the shifting around of the continuum. But we're going to dig into that over our 3 days together. So today we're going to look at some of the earlier strategies. So I said this last time, but basically when we first learn to multiply, we almost all start with this particular strategy, modeling composite units and counting by ones. And we're going to see a video a little bit later of a student using this strategy. So if you're not sure what that looks like, don't worry, we'll dig into it. And then probably for many of us, if you're older, I'm not going to say how old, but if you're older, you probably then went to memorization. Once you kind of understood multiplication, you could draw out the multiplication fact that you were being asked. You probably then kind of dug into memorizing those facts. And on the continuum, we call it something a little bit different when we talk about automatic retrieval as opposed to memorization. But essentially, knowing that fact in less than 3 seconds is kind of the research benchmark for whether or not that's a memorized or automatic fact. And that's what we would have done. And some of you shared in that text chat at the beginning that maybe there were some that tripped you up because you had memorized that fact. And somewhere along the way, you kind of memorized, a couple of them got confused with each other, or you memorized one incorrectly, and that's pretty common with that memorization technique. And so I shared this idea from Alex last time too, that memorizing those facts and procedures is not enough, and actually it never was. It just is not going to serve it. It's not going to serve us in the long run. We actually need to have more than that, because although having our multiplication facts is important, and being able to do maybe an algorithm, that might be important. That does not actually mean that you have developed multiplicative thinking and multiplicative reasoning. So those two things are not the same. Being able to pull up facts from memory and being able to perform an algorithm doesn't mean that you have multiplicative reasoning developed. And we're going to hopefully over the 3 days dig into a little bit more about what that means too.
I think that's a good point. Yeah.
Thanks for that clarification between memorization and automaticity.
Yeah, that's something was new for me, for sure. So because between those two extremes that I was talking about, this modeling composite units and this using automatic retrieval, there's a whole lot of really important mathematical territory, particularly in this green region, that we actually want our students to get a handle on and to understand, so that this is where multiplicative reasoning, this is the birthplace of multiplicative reasoning, if you will, is in this green section. So we don't want to bypass it. Before I can talk about multiplicative reasoning, I have to talk a little bit about cardinality. And cardinality is a key idea, as you can see, because it's located down on the bottom part of the continuum. And I'm just going to use the annotation tool here to help explain what that is for folks who don't know, because I certainly didn't know what that meant a few years ago. I'm going to turn off the pointer. That'll help me out. Okay, so I'm going to, wait a second. That did not go the way I planned. Let's try this again. Turn this off. Turn off the pointer, then turn it back on. That'll work better, I think. Okay, so when students first learn to count objects, they assign one number word for each object. So for example, they would say here, now I can't get rid of it. They would say here, 1, 2, 3, 4. But if you ask them, so how many hearts are there? They might just say 1, 2, 3, 4. And they don't know that that last number word that they said actually means the whole set. The number 4 represents the whole set and not just this last one. Sometimes when I'm working with young children, I'll ask the question that I just asked. So how many are there at the end, just to see if they know? Or I might ask, where's the 4? And sometimes they'll just point to this very last one here instead of suggesting that it's that whole group that makes up the 4. And so when they know those things, then they've constructed, at least for small whole numbers, this idea of cardinality. I might pause for a second while I clear this to see if anyone has any questions that come up in the chat about that.
I think this idea is important because it helps set the table for getting them to recognize sets or groups of numbers or objects when they start leading towards their multiplicative thinking.
I think it's also interesting to add that many of our later junior or intermediate students might not see this idea because students have developed it so much earlier, but recognizing that's an important idea is key to advancing kids on towards more sophisticated strategies.
Yeah, that's a good point too, Tien, that this is what I taught grade 7, 8 in the classroom. And so this wasn't something I saw developing in front of my eyes until I went into kindergarten and grade 1 classrooms. And that's where you really see it coming on board, especially with small whole numbers like this. By the time we see them, usually even in grade 2 and 3, this for whole numbers, small whole numbers is certainly well established. So we're going to take a look at this problem and take a look at a couple of videos that you guys provided to see what young kids will do with a problem like this. So let's pretend that you have 3 packs of gum and there are 4 pieces in each of the packs. Do you know how much gum you would have altogether? So just imagine for a moment what you think a young child might do with that question. And so here we go. Now, Denise, help us out. What's this young child's name? I'm putting you on the spot.
You are. This is actually one of Sam's daughters.
Oh, okay.
I'm not sure if this is Olivia or I am drawing a blank on what the other daughter's name is. So Olivia. Sam, this is Olivia?
Olivia.
Okay.
Thank you.
Thank you, Sam.
You're welcome.
All right, so this is Olivia. Oops, that did not work the way I intended. There we go.
I have 3 packs of gum with 4 pieces of gum in each pack. How many pieces of gum do you have? 3 packs of gum. Okay, so show me 3 packs of gum. Yep. What's that? How many pieces of gum do you have?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Wow, good work, Olivia.
I want to do it again.
I love that she said she wants to do it again. So there we see a student who, to me, it looks like she understands 4 and 9. She's got some cardinality pieces there. But yet, when we ask this problem, it's kind of, there's something still missing. We're going to take a look at another student here. Let's pretend that you want to give Easter eggs to 3 people and that you want to give each person to get 2 eggs. Do you know how many eggs that would be altogether? Let's take a look.
how many chocolate eggs do we need if you give Daddy 2, Evelyn 2, and Lily 2?
2.
How many? What do you think, Evelyn?
2.
Okay, why do you think 2?
Because that's what you get. You don't get upset.
Thank you.
Those are good rules to live by. You get what you get, and you don't get upset. We have that one in my house too.
Mathematically sound.
Mathematically sound. It's very true. So we've got 2 examples here of some pretty young kids thinking about this type of multiplication problem, maybe for the first time, that they've been posed that kind of problem, and just not quite being able to, at least in these situations, to figure out what to do with those 2 numbers. Because quite often, this is the very first time that kids have been trying to think about numbers where the 2 numbers that they're being asked to work with actually mean 2 different things. Instead of it being, Easter eggs plus Easter eggs, it's now Easter eggs per person and people. And so that when we hit multiplicative types of problems, this is usually the first time that that's happened for kids. So we need a new key idea. And we don't usually start looking at the continuum and looking at the key ideas, but I find with multiplication and division, because this key idea is so central to everything we're going to talk about, we're actually going to start with a key idea, which is really unusual. And this key idea is called unitizing, and we find it everywhere in multiplication and division and all multiplicative problem types, and also in fractions, because of the relationship between fractions and multiplication and division. So you're probably wondering, like I was when I first came across that word, what's unitizing? So maybe some of you are asking that to yourselves, and if you are, you're in the right place, because that's where we're going to go next. So there's actually, unitizing is a pretty extensive key idea that takes us fairly far in our understanding of multiplication and division, but we're going to start here with some initial unitizing. So what does initial unitizing look like? Well, when students first learn to count, like we saw a little bit of there, they will count objects one at a time, 1, 2, 3, 4, and then they'll know that that means 4 pieces of gum. And at some point, they're able to also call that 1 pack. So those could be 4 pieces or 1 pack. And right here is the very beginning stage of unitizing. And that's what we don't quite see with those last 2 videos that we saw, that they can think about the number 4 and the 4 pieces of gum, or the 2 Easter eggs in the case of Evelyn. But they can't think about those 2 numbers having 2 different meanings. So pieces of gum and a pack, which is the same thing, but also different. That they can use the exact same numbers to represent 2 different things at the same time in the same, working out the same problem. So in order to figure out the first problem we looked at, which is the 4 pieces of gum in 3 packages, they would have to then iterate that those 4 pieces of gum, 1 pack, 4 pieces of gum, 1 pack, 4 pieces of gum, 1 pack, like this. And they can also then, in order to solve this problem, they actually have to then change up what they're using their numbers to do and count the packs. 1, 2, 3 packs. So just to make sure that they've got the right number. And then they would go back and count the individual gum, perhaps, to figure out how many. I wonder if there's any questions coming up there.
If you have any questions or thoughts, please feel free to share them in the chat. We know this is kind of an important, big idea. We'll give you a little bit of time to think about it.
They're all taking notes, Heather. They're getting all your information.
Got it. Yeah. So here's the same question again, and this time we're going to look at a video of another, and they are they've sorted out at least the very beginning unitizing with these numbers. So we're going to take a peek at what that would look like. Uh-oh. The other two worked, Tien, but this one says that I need to access.
Can you hit the request access and I'll see if I can fix that for you?
Yeah. It has I have 2 Google accounts, and for some reason it just likes to switch back and forth. Even though I tell it which one I want to use, it seems to be troublesome these days.
Can you give it another try, Heather? Should be good to go.
Okay, let me try. I might have to stop sharing and then share again. We'll jump back in there. Oh. There we go.
Perfect.
Perfect. Okay, so here we go. And if the other one's Olivia, then this is the one we don't know the name of, right? Sam will help us out.
She will. Or someone will.
I'm sure she'll jump in there. She'll tell us by the end. She can put it in the text chat and then we'll know.
I think she's Vanessa.
Okay.
Vanessa. That's Vanessa. Thanks, Pam.
All right.
You have gum with 4 pieces in each pack. How many pieces of gum do you have? Okay, can you show me how you figured that out? So 3 packs of gum with 4 pieces in each pack. How many pieces of gum do you have? How did you count that? Show me what you were doing.
2, 4, 6, 8, 10, 12.
Wow, good work.
All right. So we see her doing something a little bit more sophisticated at the end where she's counting, skip counting. But she is drawing out all of the all of those gums, and we can probably imagine she would have maybe originally, if she was a little bit younger, have counted ones.
Question for you, Heather.
Yeah.
What we're looking at, is this developmentally common in children?
For sure. You mean just that she would draw it out?
Right.
Yeah, sure. Especially a fairly young child like this one. It's very common for them to draw that out. Mathematics is partially about being able to visualize the situation that's going on and then attribute numbers to that situation. And so even if as the situations get more complex, we go back to using tools like drawing out and visualizing. So sometimes even for older students, perhaps they're working with more challenging numbers like fractions and decimal, expect them to think about drawing things out. if she had counted by ones, then we would call this strategy that modeling composite units and counting by ones. So what do I mean by composite units? Well, if we go back to the slide a few slides ago where we were at the end of unitizing, each of these fours would be considered the composite unit. Math researchers call the composite unit basically in an equal groups problem like this one with the gum where you're creating equal groups, it would be inside. And math researcher, education researchers call that the composite. And so she is modeling out those packs, those 4 gums, the composite unit, and then in her case, she wasn't counting by ones, but they certainly usually start that way by counting by ones. She's just a little bit more sophisticated than that. And so the key ideas that we see supporting her ability to do that is cardinality and then unitizing. This is another question that I asked a different student. How much gum would you need if you wanted to give yourself and 3 of your friends 2 pieces each? And so we'll see how she opted to solve that problem.
And Olivia K. And Haley were playing. Let's pretend that these are candies. How many would you need for you and each of your friends to have one? What's that? You said Olivia K, Haley, and then so how many would you need? 4? Yes. How many would you need if you were to have 2 for each of them?
It's hard to hear in that classroom because it's so loud, but that's normally the way it is, I think, when you're trying to do these little interviews.
That's authentic.
Were you able to kind of see what she did there?
So she put the 4 counters out and she counted them by ones, but she could hold the 4 and then count it again to get the 8.
Yeah, she kind of counted on the table back by those same 4 counters again.
Mm-hmm.
And so this is a strategy that we see a lot, often on fingers, that they'll put out, 4 fingers and count repeatedly on those same fingers. Let me see if I can show you that in another spot here. Can you guys see that?
Yep.
So oftentimes they'll put out 4 fingers and they'll count 1, 2, 3, 4, 5, 6, 7, 8, for example, and they'll use the fingers to represent that composite unit, and then just count repeatedly on the same composite unit that they put out the first time. And so that strategy is really common when kids are first learning multiplication and division, and it's called counting rhythmically because there's a rhythm to that counting, and there's a lot of features of it if you get into the nuances of it that you can look for. And we see students using it, even older students using it when we ask more complex problems. And we're going to talk about that in one of the sessions coming up. When you ask more challenging problems, we see students, particularly this one, and sometimes even the modeling composite units will come back up. And so same key ideas coming into play here. Okay, so skip counting is another strategy, and I'm going to go back to my pad here because I don't have a video of a student using skip counting, but I think lots of you probably have seen skip counting out there. And when you're just witnessing it and you're watching a student do it, they will sometimes just say the number sequence and put up their fingers to track the number of times that they've said a number. So for example, if we were trying to solve the problem, if you have 6 packs of gum with 4 pieces in each, if they had a really good skip counting sequence with 4s in it, they could go 4, 8, 12, 16, 20, 24 to solve that problem. Sometimes if they don't use their fingers, they will write out that sequence. They'll write 4, 8, 12, 16, 20, 24, and they might have to go back and check to see how many iterations they've done so that they know when to stop. Any questions about skip counting by itself?
It reminds me of something you said at one of our sessions, Heather, where it looks like kids are going to start skip counting until they get to further along in the sequence, and then they have that pause, and you can kind of see them whether they're looking in the air or their heads bobbing. And you mentioned that's when skip counting doesn't really become skip counting anymore.
Yeah, so skip counting requires that they actually have the rote counting sequence memorized. So they actually know that sequence without having to think. That's the definition of skip counting. So most of us have it for 2s, 5s, and 10s pretty solidly. We could probably go on for a long time with both of those sequences without having to think about it. But for other ones, it might be less. We might be able to get through the first 5 or 6 iterations, and then we start maybe thinking about as adults, our multiplication facts to help us out, or we might think about adding. I thought I heard someone's voice there.
What happens in the landscape between counting rhythmically and skip counting?
So you're asking a really important question. I'm going to go back to the slide with the continuum, I guess, or maybe I'll go forward to the next one. So you're asking about what happens between rhythmic counting and skip counting?
Yes.
So when skip counting is learned really authentically, it's learned through rhythmic counting. So kids will learn to say the numbers in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the researchers find that if they practice those rhythmic counting sequences enough, those other numbers start to fall away. So they get quieter at first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 16. And then over time and with practice, that those numbers fall away and they just say 4, 8, 12, 16, 20, 24, etc. Does that answer your question, Tien?
Yes, it makes me think about like the purposeful practice that we need to build in to allow students for that fading to happen.
Yeah, sometimes I think we try to jump to the end goal, right, with skip counting. And sometimes what we end up with by accident is some students aren't actually thinking about real skip counting, like with real objects. And so they know the sequence, but they don't really understand what it means with real objects.
So it's like a song.
Yeah, it's like a song. Yeah. And if you ask them to do it with real objects, they wouldn't be able to do it. Now, the video we saw earlier with the little, with one of Sam's little girls there, she obviously understands that 2 skip counting sequence because she's pointing at those 2, 4, 6, 8. She knows what that means.
Right.
Yeah. All right, we've got one more strategy we're going to look at, and I'm going to go back to the document camera for this one. To look at, so that one was skip counting, and to look at repeated addition and what that one would look like. And we'll use the same problem just to make things a little bit easier for ourselves here. With repeated addition, it can look like several things. And one of those is if they do it mentally. So if they do it mentally, they might know a couple of them at the bottom. So they might know the double, 4 plus 4, that's 8. And then they'll do 8 plus 4, and then 12. And then they'll do 12 plus 4 in their head. And they'll probably be tracking as they're adding in some way, because it's hard to do all of that and remember how many you've done. So so they're at 16 and they add 4, and they get to 20 and they add 4 more, and then they get to 24, and that's 6. So they stop and they know it's 24. Quite often in school, we will see them write out the 6 4s, and they'll do that first. And then they don't have to hold all that stuff in their head. They know when they run out of 4s, then they're done. And then they might do some really interesting things here to add them up. They might even combine them and then add up 8s, for example. But even if they do something that's, looks pretty nice and sophisticated here, I would still call this repeated addition, because they're thinking about it. How they're setting up that problem is using repeated addition. And I think we're pretty familiar often with that one in schools. And we often will tell, I know I have said to my students that, multiplication is really just a quick way of doing repeated addition. And it certainly does get us to that territory. But in subsequent sessions, we're gonna talk a little bit about how multiplication might be more than just repeated addition. And that might help us out. Okay, so we've got using repeated addition, and again, same key ideas so far that we've investigated. So the bottom part of the continuum has been pretty straightforward so far. Okay, so we're rounding out to the very end. We've got only a couple of minutes left, but I know that folks are going to want to know what happens when kids get stuck. So how do we help students move forward if they're kind of a bit stuck? And one of the places that kids will get stuck, and I'm just going to go through this, and I'll talk about this cornfield analogy, I guess, at another time when we have a few more minutes to dig into it. But I know that you guys want some real practical things that you can do to help your students progress. So one of the places where they get stuck is on counting, is in that modeling composite units and counting by ones. And we even see junior students who will try to solve 6 times 7, for example, this way. And you were saying, Denise, you saw a student the other day doing something like that in junior. Yeah. So they can get stuck here. So what are some of the things we can do? So one thing that we can do is we can use quick images to help encourage subitizing, which is the ability to just look at a set of objects and know how many are there without counting. So here, most of you, I'm sure, did not have to count how many pumpkins. You just looked at it and went, yep, 6. So that ability is called subitizing, and we can capitalize on that along with students' ability to double. And so we could show an image something like this. Sorry, I'm gonna skip through these ones because I just explained it quickly. And there it is on the continuum just before. So a little quick image like that. for example, and students could then try to calculate how many pumpkins did they see. And I'm not sure if that was too fast for folks. I can show it one more time. And because it's only on the screen for a short time, they actually can't count. They have to use their visualization to to remember what the image looked like. And we actually have a lot of different ones that they could progress to. So they could progress to that image, and you could progress to this image, and you could play around with the different things that they might do, how they might see those, and how those facts might be connected. I'm really cognizant of the time, and I know you guys are too, so I'm just gonna keep going here. So number 2, use numbers that open up skip counting. So that composite unit that I was talking about before, if we put 2, 5, and 10 inside there, we are gonna open up skip counting for our students in a way that other numbers force them perhaps to count because they don't know the skip counting sequences. So equal groups problems have the following 3 components. There's the number of groups, there's that composite that's inside, and we've got that total or subtotal. So putting 2, 5, and 10 inside there, inside the group, will really support those single counters to try something else, because they know those skip counting sequences that Denise was asking about earlier. Number 3, they can use an image to support some kind of rate problems. So rate problems are slightly different from the equal groups problems that we were looking at with the packs of gum, because what you're actually counting, that thing that's the composite, is a little harder to visualize and count. So here we've got jars. They might have a certain number of milliliters of jam in them. Milliliters of jam are harder to draw out and count individually. We might do a problem that has speed as one of the elements. And so speed, at kilometers per hour, that's a lot harder to draw. It's more abstract. Here's another example. We've got Tien going to the market to buy grapes to make delicious jelly. The vendor sells bags of grapes for $5 each. So $5 per bag. How much money does Tien spend if he buys the grapes shown? So there's another rate problem, $5 each, with something that's maybe a little less likely to be drawn out and counted by ones. I've also put 5 in the composite there to really double bang for my buck, to help them move away from counting by ones.
Intentional planning.
Yeah, there you go.
There was a question. I'll put these images in our show notes if that's okay.
Yeah, sure.
And teachers can give them a try and give us some feedback.
Yeah, that'd be great. So the 4th thing, strengthening their additive thinking. So if we go back and we look at that drawing that Pam Harris we were looking at, we need to have additive thinking before we can develop multiplicative reasoning. And so if our students are still counting by ones, they probably have a gap here in their additive thinking. So I just put a little illustration there of, working on some additions and maybe some carefully selected sequences of problems that might help them move away from counting on, which is probably what they're doing a fair bit of when they're adding, to taking leaps and really having stronger additive thinking skills. Oh, there, I even put the image in there so we could see it, that down here, we need to build this before we can build up into here, so. And then the other one is exploring patterns that support place value understanding. So I've got a little picture of our $10 bill here. So here's a problem you could work at. This is maybe bigger numbers for older students, but you can change the number. So you're having a yard sale. You go to the bank to get change. You ask the teller to give you $345 with as many $10 bills as possible. How many $10 bills will you get? And so some students will have to figure that out and work that out. They won't know right away how many fills that's going to be.
It won't be 4.
It probably will be more than 4, hopefully. Yeah. So that takes me to the end of my section. And I'm sorry I went over, but you guys are very gracious.
Thank you. We're going to quickly wrap up, but if you would like to learn more, or you're looking for additional resources, take a look at what to look for. It's in every school. In the show notes, there's links to the Guide to Effective Instruction for Numeration, Volume 3, which focuses on numeration, and also check out the e-workshop resources and modules. Links for that are also in the show notes.
Again, if you need to learn more, you can always, chat with a friend. Teachers are great for that. Connect with a coach. Go to the program department blog. Get your hands on a copy of that book. Again, we got a whole bunch more sessions coming up. Heather gave us a whole wealth of information in this session, and there will be lots more coming in the next couple of sessions. If anybody has some questions, we're going to stay online for a little bit and see if we can answer some of those. There also is a QR code that is going to come up on the next slide that if anybody wants to give any feedback or, again, any questions arise, you can quickly post them there for us. I'd like to thank Heather for joining us again today. And thank you for all of our participants. Hope you have a great night.
Thank you very much.